In this video, I'm going to go through the process of adding harmonics to create a triangle waveform. And I'm going to be starting from the point at which I left off in the last video where we had the square wave form, because the triangle waveform also only contains the odd numbered harmonics, as does the square wave. However, the relationship in levels is different. Instead of being, for example, the seventh harmonic being 1/7 the level of the fundamental, it's 1 over the harmonic numbered squared. So it'd be 1 over 7 squared for the seventh harmonic, or 1/49th the level. 1 over, instead of being 1/9 the level of the fundamental, it would be 1 over 9 squared, which would be 1 over 81. And for the fifth harmonic, it'd be 1/25th. Instead of being 1/5, and for the third harmonic it'd be 1/9 instead of being 1/3. So to set those levels, I'm going to just go through and make the change now. So the third harmonic is going to be set at minus 19.08 dB. The fifth harmonic is going to be set at minus 27.95 dB. The seventh harmonic is going to be set at minus 33.80 dB. The ninth harmonic is going to be set at minus 38.17 dB. And the 11th harmonic is going to be set at minus 41.66 dB. That gets the relative levels of the harmonics, but that doesn't tell us the whole story. So let's go ahead and see how that looks. There's one other thing that we need to do, and I'll explain that in a minute. But let's look at what this looks like. Okay, it looks kind of like a sine wave, but it's, I guess, more dome-shaped than anything, because it kind of gets a little vertical here, more so than a regular sine wave would look. So what's going on here? We've got the harmonics at the right level. All right, this is the correct relative levels, but we're not seeing the triangle wave shape. Well, what we need to do is the third, seventh, and 11th harmonics. In fact, basically starting with the third and then every other odd harmonic, those need to be phase inverted from the others. So we need to invert the phase of the third harmonic. And we can do that using the utility plugin in Live, or if you have another similar plugin in your DAW, you can just invert the phase. So I'll select phase L and phase R. That inverts the phase of both stereo channels. And so, in fact, let me just solo the third harmonic here, and we'll see how that looks in the display. So notice how, let me go ahead and do it again. Notice how the sine wave is inverted in phase. In other words, it moves toward the negative amplitude rather than the positive. Okay, so if we compare it to, for example, the fundamental frequency, in fact, if I pan one to the left and one to the right, play both at the same time. Now we can see that the fundamental, which is the blue, that's been panned to the left, and that's at a frequency of 200 Hertz. And then we see the third harmonic, which has been panned to the right, and its phase is inverted. So it starts in a negative amplitude, okay, versus the sine wave. In fact, this would probably be the best point to look at it right here, where or here. Actually, here would be better, because this would be the start of the next cycle for the fundamental frequency, and it's moving in a positive amplitude direction. And then relative to that, the phase of the third harmonic, which is represented by the green line here, is moving into the negative amplitude direction. Now it's much smaller because the amplitude is a lot smaller in the third harmonic than in the fundamental, and that's because we have it at a much reduced level. It's at minus 19.08 0.08 or minus 19.1 dB. If I bring that up to 0 and then play these, now we can see the phase relationships between these two waveforms. So we see the blue wave representing the fundamental moving in a positive amplitude direction, and the green wave representing the third harmonic, which has been phase inverted, and that's moving in a negative amplitude direction. It starts its wave cycle in the negative. So what happens is when you're looking at this in a spectrum analyzer, you really can't tell that this particular frequency is at a different phase compared to this one. Okay, if I bring these back to the center for panning and then just play it and freeze it, there's nothing in this display that indicates that the phase of the 600 hertz frequency is inverted compared to the phase of the 200 hertz frequency. All right. So just be aware of that. You know, when we're looking at the relative harmonics levels, that's just showing the level difference. It's not showing anything to do with phase. Now, with that said, in order to achieve the triangle wave, we do need to invert the phase of every other odd harmonic. So in this case, the third harmonic has its phase inverted. The fifth, we would not invert its phase. The seventh, we would invert its phase. The ninth, we would not. The 11th, we would invert its phase, and that's it for this particular exercise. So now we can play, I can bring in each of these harmonics at their correct level. So let me make sure that I return the third harmonic to minus 19.08, which represents 1/9 the level of the fundamental, and unfreeze the displays. Even now, just these two harmonics, having the third harmonic, having the fundamental and the third harmonic have a phase inversion, we already start to see more of what looks like a triangle wave. And so now I will add the rest of the harmonics. And there's our triangle wave. Now if we added more, then it would get closer and closer to the ideal triangle wave. So it's pretty interesting. And that's it for this video. I'll see you in the next video.